Alright, let's take a look at how you can join decoders together. So I had mentioned in the session that our decoders had multiple enables, and that was so that you could string them together. So if you look at this page in your textbook, oh, now I lost it, there we go. So if we look at this page in our textbook, we see that if I had a 2 to 4 decoder and I wanted to use it to make a 3 to 8 decoder, then I could do that as follows. So if you look at the first decoder, that works the way we talked about it in class, that if you have the number 0, 0, then you would get the output 1, 0, 0, 0. And if you had the number 0, 1, you would get the output 0, 1, 0, 0, and 1, 0 would give you 0, 0, 1, 0, and 1, 1 would give you 0, 0, 0, 1. Now, of course, our the decoder that we looked at in the lab was active low, so it did, rather than having the ones, it had the zeros, so it looked like where's my eraser? There it is. It looked like for 0, it looked like 0, 1, 1, 1, and for 1 it looked like 1, 0, 1, 1. No, it's in the wrong place. If our number looked like Y3, Y2, Y1, Y0, if our input was 0, 0, we would get 0, 1, 1, 1. And if our input was 1, 1, we would get 0, 1, 1, 1, because it was active low. Okay, now what this combining of the decoders does is it takes your third bit. So our third bit, so let's say we had a number like 1, 0, 0. If that third bit is 0, then if the third bit was 0, so like if I had 0, 1, 1, so this is 0, then this not makes it 1, and you combine that with the enable, and you get a 1 here, and this one is enabled. But since this was a 0, this is a 0, so this is going to be a 0, so this one is not enabled. So if I have a 3-bit number, if the first bit is 0, then I'm only using the top part, and the bottom part is all going to be zeros. But if my third bit is 1, then that makes this 0, and then when I take it and it with the enable, that enables this second one instead of the first one. So how does that work with a number like, say I have 1, 0, 1, which is the number 6. Okay, so the way it works is the third bit is 1, so this top one is not enabled. The bottom one is. And now since the bottom one is, it's going to take these 2 bits right here and figure out what they are. So those 2 bits correspond to 1, and 1 is right here. So this gets us the output of 5. So how do you make a 3 to 8 decoder using 2 to 4 decoders? It's the same basic idea of, how do you make a 4 to 16 decoder, which is what you will be doing. Okay, so let's think about how this would work. If I had a decoder that had an enable, and yours have 3 enables, so you'll have to look at it and figure out how to make that work. And this one has 0, 1, 2, 3, 4, 5, 6, 7, 8, and 0, 1, 2, 3, 4, 5, 6, 7, 8. And I have a 4-bit number, so I have W, X, Y, Z. Then I take W, or take not W, and I AND that. Actually, I don't think I need to AND it. I can take not W and put that into an enable. So you have to look at the 3 enables. You'll have to look at the data sheet, and I know one of them is enable high, one's enable low. You'll have to figure out what it is. So you want to take this first one. So if this is a 1, you want that to disable the top one. If it's a 0, you want it to enable the top one. Similarly, if it is a 1, you want it to enable this bottom one. And if it's a 0, you want it to disable the bottom one. Okay, so how does that work? So let's say I have 1, 0, 1, 1. If I have 1, 0, 1, 1, I want to disable the top one. And then I send these 3 numbers to the bottom one. These 3 numbers make the number 3, so that would be right here. But what is my entire number? My entire number is 11. So let's see if I put these all together. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, no 8. Forget the 8, just 7. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it works. Okay, so let's say I had the number 0, 1, 1, 0. That's 6. I want this 0 to disable the bottom one, and then I just send these 3 numbers to the top, and I get 6. So do you see how that works? So what you want to do is you want to take your 4-bit number. So starting from the beginning, let's say I have a function that is the sum of some min terms, 1, 3, 8, 9, 11. Like I said before, if we had a 0 to 15 decoder, all we'd have to do to make this function is to put our 4 variables in, and then OR together the min terms, and that would be our answer. So how are we going to do this one? We're going to make a 0 to 15 decoder by having our first decoder have the numbers 0 to 7, and our second decoder having the numbers 0 to 15. And the way that works is you take your 3 digits, and those are going to be your inputs into here, as well as your inputs into here. And you're going to make this most significant bit when it is 0 to enable the top one and disable the bottom. And if it is 1, you make it enable the bottom and disable the top. Okay, that explains it all. If you want start to finish, keep listening. Okay, start to finish, keep listening. So let me look up the data sheet. Okay, so let's say my function is the sum of the minterms 1, 5, 10, 11. Alright, so, and this is, I will have X, Y, Z, W. Alright, this is going to be the one I use for enabling or disabling. Y is going to go to A2 on both of these. Z is going to go to A1, and W will go to A0. That makes these first 3 numbers, if I had the number, let's say I had 10, that would be 1, 0, 1, 0. This is X, Y, Z, W. And so that would, W is going to be equivalent to A0, Z is equivalent to A1, and Y is equivalent to A2. So you're going to do that. Okay. Then for the enables, let's look at the enables. The enables are E3 needs to be high, and E1 and E2 need to be low. E3 needs to be high, and E1 and E3 need to be low. Alright, so you want to take X, and you want X to go to E1 on both of these. So if X goes to E1 on both of those, if X is 1, then no, I don't want it to go to, I want, hold on. I want X to go to E1 on that one, and I want not X to go to E1 on that one. Or I could have X go to E1 on the top one and X go to E2 on the, yeah, that'll work. Okay, so if X is 1, E1 needs to be high in order to be enabled. So if X is 1, that would enable this one. E2 has to be low to be enabled. And so if X1, if X is 0, that would enable this one. if it's 1, it would disable that one. And then you could attach both of these to ground, and you could attach this one to VCC and this one to ground. And then for our particular function here where I said 1, 5, 10, 11, so on our top one, these are the outputs 0, 1, 2, 3, 4, 5, 6, and 7. And here we have 0. So, and then it would continue on to this one to 8, 9, 10, 11, 12, 13, 14, 15. And so our function would be the OR of 1, 5, 10, and 11. And if you don't have an OR that's big enough, you can just chain together ORs. So you can have the OR of 2 and then OR that with others. All right.